Hello students, myself Porn Chandarao, I am a physics faculty. Today I am discussing about vectors. Why first we are discussing about vectors mean it is one of the most important chapter for understanding that remaining all the chapters also. At the same time from this chapter in JEE mains and NEET exam also question will be getting. Here first we are discussing about the vectors. In the vectors, vector and scalar, the first one is. Second one is angle between the vectors. Now, before going to discuss about the vectors, first we are discussing about physical quantity. What is the physical quantity? A quantity is quantity which can be measured. All measurable quantities are called as a physical quantities. Here quantity which can be measured, that is called as a physical quantity. Here for example length is one of the measurable quantity. For example any object you can take, one rod. Let us consider a rod. What is the length of the rod? What is the length of the rod means here we will take as a either 20 centimeter. You can take here the length of the rod equal to 20 centimeter. Here length is the measurable quantity. Otherwise any one person height will be measured. The height of the person equal to, for example generally you are using that practical unit 6 feet or 5.8 feet in the way also. Otherwise in terms of centimeter also you can say 170 centimeter or 160 centimeter. Height or length both are similar quantities actually. That's why here length is the measurable quantity, that's why it is called as a physical quantity. Next mass, any quantity mass you can measure. For example one mass of the person that is equal to 10 kg or generally saying as a weight, but instead of the weight generally you can take on the weighing machine you are standing, there will give as a 65 kg, it is mass only. Now that's why mass is the measurable quantity. Next to time, what is the time now? Generally will take as a 10:15 or 11 o'clock, otherwise 12 o'clock. It is also time also measurable quantity. These all measurable quantities are called as a physical quantities. Next one is the temperature. What is the today temperature or what is the yesterday temperature? Yesterday temperature is very much. Then we are saying that value 40 degree or 45 degree. In summer season some areas are getting the temperature is 48 degree centigrade or 47 degree centigrade also. Or some areas in winter season getting that 7 degree or 2 degree, 3 degree, very low temperatures also it will be formed. That's why temperature also one of the measurable quantity. That's why it is also called physical quantity. Next electric current. The current passing through a conductor 2 amperes or 10 amperes or 1 ampere or 20 amperes also can take. Here ampere is the unit of current. The current is measured in terms of amperes. That's why electric current also measurable quantity. That's why these all measurable quantities are called as a physical quantities. That is the mean of physical quantity. That's why here statement is given. What is the physical quantity? A quantity is quantity which can be measured. A quantity which can be measured, that quantity is called as a physical quantity. Next, physical quantities have numerical magnitude and unit. Any physical quantity also you are taking, it is having numerical magnitude one is and another one is unit. It is a numerical magnitude and the second one is unit also. For example, if length of an object is 100 centimeter, length of an object 100 centimeter, here then 100 is, here only have the numbers see that 100 is its numerical magnitude. Next, and centimeter is the unit of measurement. Centimeter is the unit of measurement, 100 is numerical magnitude. Next, here also in this example also if you are observe, length of the rod is, I write here 20 centimeter. In this 20 is numerical magnitude, centimeter it is the unit. Like any physical quantity you are taking, it is having one numerical magnitude and unit also, then only it can meaningful. Either unit is not there, the physical quantity is meaningless. For example, if you write any number, I write the 10 here. What is the 10? That is counts anything also. You can write here 10 centimeter, you can understood. He is explaining about the length. Otherwise, I write here 10 kg, you can understood. I am explaining about the mass. Its kg means kilogram there. I am explaining about the mass, you can understood. Otherwise, 10 hours, HR means hour, that 10 times of 1 hour it is. This is numerical magnitude and unit. That hours means easily can understood that is the about time. It is 10 hours is about the time. Time is the physical quantity. Here length is the physical quantity. Here mass is the physical quantity. But only number writing you can't able to understood anything also. That is the importance of a physical quantity. Next, the physical quantity is classified into two types. One is the vector quantities and another one is the scalar quantities. Now, first we are discuss about vector quantities. Here first we see what is a vector, the statement about the vector. A physical quantity is having both magnitude and direction and that obeys laws of vector addition are called vectors. Laws of vector addition, that point be remind, it is important also. Here any physical quantities having both magnitude and direction that obeys laws of vector addition are called vectors. Here the physical quantity having that three things, one is the magnitude and the second one is the direction and the third one is laws of vector addition. These three properties are having the physical quantity, then the physical quantity name is called as a vector quantity. Try to understand very clearly. If any quantiles you are taking, the quantity first having the magnitude, second direction have or not, and the third one is laws of vector addition obey or not. These three are verifying, these three are satisfied, then the physical quantity is called as a vector quantity, can say that. Next, here these vectors are again two types of classification have here. One is the symbolic representation, the second one is pictorial representation. First one is what is the symbolic representation. In this, if you are observe, it is called as a bar. We will see what is the symbolic representation. Any vector quantity is denoted by a small right arrow, this point be understood, small right arrow. Any vector quantity is denoted by a small right arrow over it. If it is a vector quantity, it should be denoted by a bar. It is read as a bar. We will see that it is called as a read as a bar. Now here A, above the letter A, if you are observe that small right arrow have, generally A you are taking, left arrow is not will take, generally we are consider it is wrong. Here what is the correct means, in this form is required always. A small right arrow have above the letter, that is the representation of symbolic representation of vector. Now for example velocity. Velocity is symbolic representation is V bar. We will see that velocity generally taken as a V, इसको ऊपर bar have, see that with arrow mark. This is also small right arrow. This is the symbolic representation about the velocity. Next quantity is acceleration. Here A bar. Here A bar. There also will see small right arrow is there. Now it is the symbolic representation about acceleration. The next one is the force. Here symbolic representation is F bar. Generally force is denoted with the F. इसको ऊपर bar है. Now this bar represents, it is the vector quantity. For any physical quantity also, for example displacement have. Displacement. Displacement is denoted with the S bar. Here bar like writing with a small arrow, right arrow mark, then this quantity is called as a vector quantity. Easily you can understood the point. Next, like For example, electric field intensity. Electric field intensity is denoted with the E bar. This is also bar you are writing means that quantity is a vector quantity, you can understood that. Next, magnetic induction, it is denoted with B bar. It is also vector quantity. Next, torque, torque also vector quantity. Angular momentum also vector quantity. Like number of quantities you can take. For example of symbolic representation. This is the symbolic representation of electric field intensity. It is the symbolic representation of magnetic induction. It is the symbolic representation of displacement. Next, pictorial representation we will see. In the pictorial representation, just this arrow, right arrow mark only taken. That arrow mark is just extended. When it is extended, here getting the 2 points. First point name is called as a tail. The second point name is called as a head. It is this arrow is called as a head. Arrow direction represent as a head, and this initial point name is called as a tail. Next, this length have from here to, we will observe this length will give as a magnitude. It's mean this arrow give the direction, this length will give the magnitude. That's why generally in that vector statement, if you are observe, one is the magnitude and another one is the direction. These two things also will explain by this arrow only. The next one, to describe a vector quantity, we require, what are required to describe a vector quantity? For that, first thing is the specific unit of that quantity. One specific unit is required for explaining that vector quantity. Next, the number of times that unit is contained in that quantity. The number of times that unit is contained in that quantity. The unit, how many times it is contained, that is also important. Next, the third one is the orientation of that quantity. These three things are required to describe the vector quantity. First one is specific unit, second one is that unit is contained, the number of times the unit contained in that quantity, third one is orientation of that quantity is required. For this, we will explain with one example. What is the example for this? For example, one girl is running with a velocity 5 meter per second. Here I will take a girl is running with a velocity, 5 meter per second. Here meter per second is unit. For the velocity, this velocity is measured in terms of meter per second in SI system of units or international system of units. Here meter per second. Next, this 5 is meter per second unit. The unit how many times? The unit is how many times have, that is represented the 5. Here this unit is how many times are have? 5 times are there. That's why this velocity equal to 5 times of meter per second. It means the girl is running with a velocity 5 meter per second. Here 5 is the numerical value, meter per second is the unit. Unit means first point, if you are observe, the specific unit of that quantity, meter per second is the one specific unit for velocity. Next to second one is number of times of that unit contained in that quantity. How many times are contained? 5 times it is contained. Next to third one is the orientation of that quantity. But in this velocity covered first 2 points, but third point is not covered. Orientation means what is the direction, which direction the girl is running, east direction, west direction or northeast direction, any direction you can take. Otherwise, here if I take the one arrow, the girl is running towards right. With respect to me, it is my right hand. Towards right, the girl is running. Like also can explain. Otherwise, the girl is running towards the school. To one specific direction you are mentioned there. That is called as a orientation. Are you clear that? Now, here specific unit they are mentioned. Next to second one is the number of times of that unit contained in that quantity, and the third one is the orientation of that quantity. These three things also now will be covered. That is the describe a vector quantity. Next, in this, for this also with one example we will explain here again. If we want to represent a force of 5 Newton, force is the physical quantity, 5 Newton, 5 is the magnitude, Newton its unit, measurable unit, acting 45 degree north of east. That is, if we want to represent a force of 5 Newton acting 45 degree north of east, that is how to represent, we will see. First, we choose suitable coordinate system. For that, for it will represent, first we are taking that suitable coordinate system. Here observe, it is a suitable coordinate system, it is a two-dimensional plane. Here right side have the east, left side is the west, upper side north, lower side is south. On paper always we are taking same representation of the directions. Right side east to, left side west to, upwards north to, downwards south it is. Next, for the direction 45 degree north of east, the reference is east. North of east, from this 45 degree north of east, east is the reference. The reference is east, then turning 45 degree towards north, that is the mean of. Here reference is the east, that is why this is north of east taken. North of east means making an angle with east also 45 degree, making an angle with north also 45 degree, that is mean of north of east. But to north of east given, then we take the vector making an angle with east only. In case east of north given, then you are taking angle with the north. Here this angle is 45 degree with the east. Now here see that the magnitude of vector modulus of AB bar, initial point taken as a and this head, that head you are taking, it is denoted with the B. Now this length will give as a AB, that AB, the magnitude of AB or the modulus of AB equal to 5 Newton, that 5 is the magnitude, N represents, that is about force, measurable force as a system, international system of unit is Newton, that is. Now it is the direction here mentioned, magnitude also mentioned. Here previous point based, if you are observe, the specific unit of that quantity, first one is specific unit, it is a Newton, specific unit have. Next to second point, see the number of times that unit is contained in that quantity, number of times the unit is contained, 5 times the unit is contained. Next, third point is the orientation of that quantity. Orientation mean it is the direction. What is the orientation here? North of east is the orientation. It is the example for representation of the describe the vector. Next, it is already discussed about that vectors. The next point is what is a scalar? What is a scalar means physical quantities having only magnitude are called scalars. Which physical quantity having only magnitude? Here not mentioned direction, does not have any law of vector addition also. The 2 points also not given, but in vectors what is given? The physical quantities having magnitude, direction and obey the law of vector addition. That physical quantity is called as a vector quantity. But here the physical quantity having only magnitude, it is called as a scalar quantity. These quantities are called scalar quantity, means only have the magnitude, there is no direction. Here time, example is given for scalar quantities time. Time is the scalar or not, just verify that. For example, present what is the time? 12 o'clock. 12 o'clock means it is only have the magnitude, there is no direction. You are giving only that magnitude, not have any direction. 12 o'clock, any specific direction you are not able to mention there. That is why definitely time is scalar quantity. Next, second one is volume. For example, one bottle containing 1 liter of water. One bottle contains 1 liter of water or 2 liters of water. Liter is the practical unit for the volume actually. Or 10 liters of water, 20 liters of water, or oil taken 1 liter of oil, or in meter cube you are taking. For example, volume of the body equal to 10 meter cube or 10 centimeter cube also. But this volume does not have any specific direction, that is have only the magnitude. That is why volume also scalar quantity. These quantities are having only magnitude, does not have any specific direction. Next one is the density. Density equal to mass by volume. Mass by volume. Generally mass is the scalar quantity. Here given that example also mass. Mass is the scalar quantity. Mass means any body mass also you can take, either 2 kg or 10 kg or 5 kg, just you are giving that word only. It means only you are represent the magnitude, does not give any specific direction. 2 kg right side, 2 kg left side, like you are not given any answer. For example, that object mass how much means you are saying that object mass is 10 kg. That sentence is completed, meaningful sentence that. In case meaning is not completed, then only it should be changed. But mass of the body means 10 kg you are given means it is a meaningful sentence that. That is why this mass also having only magnitude. That is it is also called as a scalar quantity. But density equal to what? Mass by volume. Mass is the scalar, volume also scalar. Scalar upon scalar will give scalar again. Scalar upon scalar will give scalar only, that is. That is why density is the scalar quantity. Temperature. What is the today temperature? 20 degrees centigrade. Complete, you can understand that. When you are giving the answer, today temperature is 20 degrees centigrade. Or what is yesterday temperature? 40 degrees centigrade. Or what is the temperature of the water? 60 degrees centigrade. Or what is the temperature of the ice? 0 degrees centigrade. That is meaningful. That is why. But it is always you are giving that answer is only one particular magnitude only. That is why temperature is called as a scalar quantity. Next, work. Actually, work explanation is coming in the dot product also, but simply we will give here what is the work means. It is does not have any specific direction. How much work you are done? Generally, we are represents in terms of the joule. I done the work is 2 joule or 10 joule or 20 joule only that. That is why work also does not have any specific direction. It is also scalar quantity. Next one is the energy. Energy also scalar quantity. Energy also 2 joules, 3 joules or 10 joules like only. Generally, we are taking that magnitude only. Does not have any specific direction for energy. That is why it is also called as a scalar quantity. Next, electric charge. In that lower class also having electricity. What is the electric charge? Electric charge means 2 coulomb or 10 coulomb or 20 micro coulomb. These are values only you are taking that. Just have the magnitude. Charge right side, charge left side, charge upwards, like not giving it anywhere also. That is why it is having the magnitude means it is also called scalar quantity. Next, electric current. This is the important. Electric current generally magnitude have. If you are taking electric current I equal to 2 ampere. 2 ampere current is passing through one of the given conductor. Here 2 is the magnitude. Okay. This is ampere, that is the SI unit of current. But current have the direction. What is the direction of current means? Opposite direction of flow of electrons in a conductor. Opposite direction of, let us consider a conductor. One small area of cross section of the conductor taken. In this, the electrons are, if you are given the if you are applied a potential difference across the conductor, then electrons will be moving from one end to another end. For example, electrons are moving in the direction taken. Electrons are moving from right to left. The conventional direction of current through the conductor, opposite direction of flow of electrons. The conventional direction of electric current is opposite direction of flow of electrons. It is the direction of current then. Now current have the direction also, magnitude also have, but it is considered as a scalar quantity. What is the reason? We will see that here in the note point. A physical quantity having magnitude and direction but not obeying law of vector addition is treated as a scalar quantity. Physical quantity having magnitude, direction but not obeying laws of vector addition is treated as a scalar. Now electric current is a scalar quantity. For this explanation I will give here. Here taking the diagram also, see, it is one of the conductor and it is the one of the conductor. Angle between both conductors are theta. Just it is shifted to here. This is the theta. Angle between both conductors are theta. Electric current is always associated with the direction. Electric current always have the direction, but it is not a vector quantity. It does not obey law of vector addition for its addition. Here upper side one conductor have, lower side one conductor have. Through this conductor I1 current is coming. It is the direction of current, to try to understand. It is also direction of current. Here through this conductor I2 current is coming. Here I have the junction. At the junction both currents are met and through this conductor the total current is passing. How much current is passing? I1 plus I2 current is passing. The resultant current through the conductor is independent of angle between the conductors. Here this angle may be 30 degree can take, 60 degree can take, 90 degree can take, whatever may be the angle can take in between the conductors, but the resultant current equal to I1 plus I2 only. The resultant current is independent of angle between the conductors. The resultant current is independent of angle between the conductors. The resultant I1 and I2 is I1 plus I2. By Kirchhoff current law, the resultant does not depends on angle between currents I1 and I2. That is the reason. For example, two vectors I will take. It is one of the vector quantity, it is the one of the vector quantity. Just our convenient to known quantity will take. What is the known quantity means? Force. In lower classes also will come that quantity, force. Explanation about the force. Here this force F1 equal to 4 Newton. This force F2 equal to 3 Newton. 3 Newton force, 4 Newton force, both are perpendicular to each other. From this diagram you can understood angle between both vectors is 90 degree. Resultant force definitely existed in between F1 and F2 only. For example, here one object you are taken also, in the direction 4 Newton force applied, in the direction 3 Newton force you are applied, then this object is moving in the direction. It means the resultant force acting in the direction. Then this 3 Newton, this vector you can shift. Without changing the direction, the vectors can able to shift from one place to another place. Now this value is 3 Newton. Here if you are observe, it is one of the right angle triangle. See, from the right angle triangle, F square equal to 4 square plus 3 square. Hypotenuse side square equal to side square plus side square. 4 square plus 3 square means this is 16 plus 9. Then here write F square equal to 25. Then the value of F equal to 5 Newton. Resultant force is 5 Newton, that is. In case this angle is other than 90, the resultant force value is not equal to 5. More than 5 will come or less than 5 will become. Because of it is a vector quantity. The resultant force is depends on F1 and F2. But here resultant current is independent on angle between both conductors. That's why electric current is a scalar quantity. Electric current have the magnitude, direction also, but does not obey the law of vector addition. That's why electric current is considered as a scalar quantity.